The Indo-Australian archipelago is one of the most species-rich regions on Earth. Including over 20,000 equatorial islands, it contains 4 of the world's major biodiversity hotspots. A correlation between its distribution of animals and geographical history was first recognised by British naturalist Alfred Wallace in the 19th century, and has until today been of great interest to scientists searching for a rationale behind its remarkably colourful coral reefs and wide range of fauna. Climate change in the past has largely influenced the ecological dynamics of a continental shelf within the Indo-Australian archipelago, the Sunda Shelf. A shelf is a portion of continent mostly submerged by shallow seas, leaving a few elevations of land uncovered called shelf islands. On the Sunda Shelf, these islands include Borneo, Sumatra, Java, and the lesser Sundas, including the Mentawai chain in Bali. The Malay Peninsula, protruding south from the Asian mainland, is also included. This contains the countries of southern Thailand, West Malaysia, and the southernmost tip of Myanmar. During times in the past when the Earth's climate was colder, the ocean water near the poles of the Earth froze up and became trapped in ice, lowering sea levels by up to 40 metres. Land underwater became exposed, ultimately uniting the islands and peninsula into one consistent landmass called Sundaland. Terrestrial animals like amphibians, orangutans and arthropods could now disperse across land bridges created by glaciation to other islands, thus expanding their distribution across Indonesia. When the climate warmed for short periods between these glacial phases, polar ice melted and sea levels consequently rose again, separating populations of the same species on different islands. This is called allopatric fragmentation, and over time genetic drift acted independently on populations, causing them to diverge. This separation and reunification of islands by fluctuating sea levels thus helped increase biodiversity across the Sunda Shelf. However, was this the only repercussion of the Earth's climatically dynamic past? Were there limitations of these land bridge corridors that meant some species remained endemic to one island, despite having the opportunity to access another? To attribute these species distributions and their exceptionally high biodiversity to just one geographical factor is too simple. There must be more in Earth's history to explain the beautiful and highly choreographed tapestry of fauna observed within the Sundaic region's tropical rainforests, lowland savannas, and azure seas today. The giant river frog is endemic to Borneo, meaning it can only be found on this island. There are 88 endemic frog species altogether in Borneo, which is the highest number out of all the shelf islands. Sumatra and the Malay Peninsula, on the other hand, share a larger number of species, which are more closely related. If lowering sea levels permitted accessibility to other islands, then why haven't so many frogs left Borneo? The Pleistocene epoch between 2.5 million and 12,000 years ago was in particular a climatically dynamic time of rising and falling sea levels due to repeated glacial cycles. A recent sea level drop during this time was very small, only by about 30 metres, which was enough to expose a land bridge connection between Sumatra and the Malay Peninsula, but not between Borneo and either of these land masses. Java is a small island that shares a large number of its species with Sumatra. Today, the two islands are separated by an ocean body called the Sunda Strait. This strait was a lot shallower during the Pleistocene than it is today, making it easier for animals in the past to raft across. Many of Java's endemics are found in mountainous habitats, as Java emerged as an island from a few offshore mountain chains only very recently compared to Borneo and Sumatra. The importance of land bridge exposure for dispersal during cold climates is even reflected by Sundaland's flying animals. Sundaic Teldenia moths have successfully colonised Sulawesi, an island outside of Sundaland. Borneo and Sulawesi are separated by the Makassar Strait, a 20-mile marine zone that has prohibited any historical land bridge connection between these two islands. Even for a flying insect, the journey across the strait is long, and any chance of successfully colonising and reproducing in a new island after such a journey is unlikely. Interestingly, the moth is also found on Palawan, a Philippine island. There is evidence for a Pleistocenic land bridge between Borneo and Palawan, suggesting a very indirect terrestrial route was taken through the Philippines to reach Sulawesi. However, for some animals, exploring these land bridges was not an option. The habitat of these corridors mattered, and it would be suicidal for an individual relying on a dense rainforest for food and shelter from predators to expose themselves in an open savanna. The popular theory of a 50 to 150 kilometre wide savanna corridor has been proposed to run from Borneo to the Malay Peninsula via Sumatra and Java during glacial periods. In contrast, parts of the fossil record support the preservation of rainforests between shelf islands. Meanders have been recognised on some of the shelf submerged rivers, indicating they were previously occupied by riverbank trees. This would help rainforest animals colonise Sumatra from Borneo. But what about aquatic animals? What did the lowering of sea levels do for them? Well, lowering sea levels exposed deep freshwater troughs under the South China and Javan seas that joined rivers across several Sunda islands, including the Kapuas River in Borneo, the Johor River in the Malay Peninsula, and Palembang in Sumatra. This could explain why one species of river catfish is present in all of these rivers today, yet is very different to its relatives in rivers closer to them on the same island. For marine fish, the situation is rather different. Lowering sea levels meant populations of the same species were separated by more land, so this hindered their dispersal and greatly limited their distribution across Sundaland. The opposite effects of that on terrestrial and freshwater fauna. Populations of the false clownfish and giant clam are most highly diverse at the margins of the Sunda shelf, indicating their lack of opportunity to mix with other populations and exchange genes at the shelf centre. The largest driver of dispersal at larval stages for both these organisms are ocean currents. The Indonesian through flow, for example, drives water through the Makassar Strait on the southeast margin of the Sunda shelf. So, could these ocean currents also play a large role in today's distributions of marine animals and climate change? Animals that disperse further are more easily separated and thus more prone to allopatric speciation. But are geographical factors like land bridges, riverine systems, and ocean currents the only things that determine how far they can disperse? No, morphology matters too. Mammals are generally poor at crossing large water barriers because their anatomy means they are very vulnerable to hypothermia. These animals would therefore be the most reliant on terrestrial corridors to move between islands. Amphibians are also intolerant to saline waters. However, their small size means they are able to raft on bits of wood or debris to the other side. Reptiles are the best dispersers across seas due to their scaly, waterproof skin. The females of some snake species can store a male sperm for a long time or be completely parthenogenetic, which means they can reproduce without a male partner. Therefore, only one female snake is required to colonize and populate a whole new island. As a result, we can say that today's mammal distributions across Sundaland most accurately reflect those at the end of the last glacial period. Since the end of the last ice age, so about 12,000 years ago, rising sea levels of our current warm period have resulted in the formation of seaways around the Isthmus of Kra, the narrowest part of the Malay Peninsula, which has prevented the dispersal of some animals between Sundaland and Indo-Burma. This region was particularly vulnerable to a rise in sea levels, because its elevation is relatively low, and it has consistently been eroded by high amounts of rainfall in its history. Today, the Isthmus of Kra marks a transition zone between the types of animals we can expect to see in mainland Asia compared to the south of the Malay Peninsula. For example, the Malay civet cat and short-tailed mongoose can only be found in the south of the peninsula, whereas the large spotted civet cat is restricted to the north. Separation of habitats by high sea levels has resulted in a high prevalence of cryptic species, such as within caecilians. These are very similar looking organisms, but they are in the process of speciation, so cannot interbreed. But what can explain allopatric speciation within the islands themselves? Why is there such high, long-standing biodiversity, despite corridors between islands shutting only 12,000 years ago? This is too short a time for speciation to occur, so populations must have already been diverging before sea levels began to rise again. Well, another outcome of a glacial climate is forest contraction. Large areas of rainforest on the same island would dry out in response to the cold and shrink into fragments. Populations of the same species would then become separated into these fragments for the duration of the glaciation, predisposing them to diverge from one another. Rainforests at high altitudes in the highlands and mountains were less affected by the climate change, so have remained stable. Resilient, unchanging environments preserve the most species, so maintain the highest levels of biodiversity. This is called museum hypothesis. Rates of extinction also differ between Sunda Islands, affecting animal distributions. Small, newly isolated islands become highly concentrated with fauna quickly, predisposing them to a higher rate of extinction than larger land masses, although this rate will slow down as more and more animals become extinct. Interestingly, for mammals, the proportions of animals stay the same across the Sunda shelf, despite experiencing different extinction rates on islands. The only mammal family completely absent from the smallest islands are the carnivores, perhaps because they tend to be large and at the top of the food chain, so rely on a high quantity of smaller animals in order to stay fed. Finally, there is one other thing the fluctuating sea levels of Sundaland's past can't explain. Mammals in the Mentawai are generally much more closely related to mammals in Java, Borneo and the Malay Peninsula than they are to mammals in Sumatra, where there aren't very many mammals at all. If land bridges were the only factor shaping distributions across Sundaland, then why does Sumatra, the island in the centre, the island with the most connectivity, lack in diversity and close relationships of mammals to those on surrounding islands? This could be attributed to volcanism. The largest and most recent volcanic event in Sundaland's history, the Toba eruption, occurred in Sumatra about 75,000 years ago, spreading ash as far as India and causing the extinction of many animals within Sumatra. Reptiles and amphibians have since been able to disperse from other islands to Sumatra, but the biogeography of mammals remains roughly the same as it did in the aftermath of Toba due to their poor dispersal ability. The eruption has, however, created the isolation of one population that has since evolved into an entirely new species. The Tapanuli orangutan are endemic to a very small province in the north of Sumatra and started to diverge from other orangutans on the island about 3.4 million years ago, but they were not truly isolated until after the Toba eruption. The resultant extent of seclusion and endemism for such a small population has amplified their vulnerability to extinction by humans today. Habitat destruction by the Bangtang Toru hydropower project in the rainforests of northern Sumatra is currently threatening Tapanuli orangutans, and deforestation in Sundaland in general is rapidly removing the homes and resources for all its animals, replacing rich rainforests with empty savanna and malnourished soils. Southeast Asia suffers the highest amounts of deforestation in the world, which is especially threatening for a region with such impressive biodiversity and endemism. It is important that future rainforest management involves alternative ways to support humans without detrimental levels of habitat destruction, including the in-situ conservation of fauna endangered by deforestation and preservation of Sundaland's species-rich montane forests. Otherwise, we could be sending thousands of species into extinction in a matter of decades. These problems are not only up to a handful of present scientists to resolve, but also a montage of future conservationists, politicians, campaigners, business corporations, and the power of the general public in order to keep the colourful work from millions of years of evolution alive for as long as possible in Sundaland and the surrounding ecosystems of Southeast Asia.